This is the final presentation for the research study which we have completed for PLDC module in third year BSc Special IT program conducted by SLIIT. First session of this study we have put forward abstract introduction, background, research program, objectives and the references which are made under this research. With starting the first session, the final session of this research study, we need to what the safety critical system is. The safety critical systems means any failure of system can cause loss of human life or have either catastrophic consequences. Therefore, we have outlined this presentation as follows. One is basic of software in avionics systems. Number 2 is choices of programming language for avionics systems. Number 3 is assessment of candidate technologies for programming languages available here. And the conclusion is aviation electronics, and it is embedded software requires higher, safer and reliable systems. Therefore, avionics software development process is required by law for safety. Avionics system should do what it's supposed to do, and it should not do what it is not supposed to do. In other terms, there can be no any failures and no any hazards. Choice of programming language has large impact on the cost of developing avionics systems. Language for avionics systems must have to fulfill reliability, predictability, analyzability, expressiveness, and expressiveness requirement that the system seeks. Reliable language not only clears off traps and pitfalls, in it allows earlier error detections and compile time gain. Predictable language offers unambiguous language semantics, and it satisfies the static demonstration that time storage constraint or runtime support. As an example, you can take exception handling, concurrency, and memory management. Analyzability, the language expands the span of tracing between requirements and code. A programmer can map a piece of code back to a requirement, so there can't be no any. Expressive language support for application-specific real-time functionality in either terms, that is hardware interrupts. So therefore, we can see the piece of programming language that helps develop avionics systems. Early error detections technology strong type and compile time checking is important. Encapsulation and namespace control that will helpful for less data coupling. For out-of-range array indexing and integer overflow will also be help to make safer language. So less data coupling, encapsulation, namespace control, and checking of out-of-range array indexing and integer overflow. And now let's see what are the language issues with avionics systems. As I have explained in the previous slides, any language has malfunctioning in reliability, predictability, analyzability, and expressiveness will lead to an issue for options of avionics development. So next slide will we see that feature of programming language which present difficulties. Need for expressiveness, expressive power in general purpose language versus needed constraint feature usage for verifiably program. Desire for dynamic flexibility versus need for static analysis also must be considered. Desire for high level features versus need to certify the code actually has also be considered. when we are taking assessment of candidate technologies for the programming language, this will be categorized under C-based languages, ADA-based languages, and the Java-based languages. Right. So, with comparing the C-based technology, C was not designed for safety critical systems, and some intrinsic issues like integer overflow, as I said previously, cannot be removed by subsetting. Concurrency is not in C, it is only available through external libraries. That is also some weaker area for C-based technology for the avionic critical safety systems. When you are taking ADA, it is easier to subset for safety critical applications. It is popular in this particular trade called safety critical mission avionics systems. So there can be OOP can be removed. The pragma restriction and pragma profile they have introduced. Long history of success in this domain and lack standard annotation facility also available, and there was a new version of ADA is called Spark that offers one approach for this. Taking Java based technology, it is harder to subset since many issues are intrinsic. The error prone C based syntax and lexical structures and object oriented language. Subsetting for static analyzability conflicts with Java's dynamic philosophy. Now experience in producing safety critical systems in Java. Java 1.5 annotation facility useful, but it is too weak for the safety critical profile. Work on safety critical profile will require consensus building. Work in safety critical avionics system is difficult. The skill is not much the knowledge of a particular programming language. A software professional should be able to learn a new language in a short amount of time. The more critical talent is the ability to think, design and implementation with a focus not just on meeting a system's functional requirement, also on avoiding hazard and vulnerabilities. Thanks.